All right, we get going, doing some SQL stuff. Where am I? Okay, what we want to do is, one of the things about Access that I haven't figured out how to do yet is when I get my SQL view for something, is to get it so it's easier to read on the screen. So you might have to move up closer, depending on how good your eyes are. All right, let's do. Let's just create a query the way we normally do it. I'm not going to use the query wizard. I'm going to use the query design. This is a database that is actually, it's on Canvas if you want it. I think later in the course we use it for a homework assignment. It's that course registration system, but it's got professors on it, and I've got a bunch of records in each table. And so let's say I wanted to figure out, let's take all of these. Want to look at, a student's grade report. So you're interested in your grades at the end of the semester? All right, so I pull all these tables, put them on the workspace. Careful.
Can't see that well.
Yeah, and this doesn't allow me really to make it any bigger, unfortunately. Okay, so traditionally when we do this, if I'm wanting a student's grade report, so I would probably start with the student information, and I'll pick. All right, so you guys know how to do this. You know, I can pick it from the list here, or I can just go over here and double click on the fields I want, and it'll put it in the next available spot. So if I want the student ID, if I double click on that, it puts it here as the next field student ID from the table student. Okay, and I can change that if I want to. Last name, first name, so I get that. Then let's say I want to figure out what courses that person is signed up for. So I can pick the course ID from either the courses table over here, or I can pick it from the schedule table over here. It doesn't matter, because I'm going to pick it from where the course ID is equal, right? So the course ID there. Then I want the title of the course, maybe the credits, and then the professor's name. And then, oh yeah, by the way, I need the grades. All right? So what I've done is I picked fields from at least one field from each table. Okay? So now if I want to go and look at this, put it in datasheet view, and go and run it. So now I've got all these people in here in no particular order. Right? In fact, it's probably in the order in which they were entered, and that would be basically, I don't know what, no, I don't see any intuitive order here. All right, so to change the order, all right, let's while we're here, let's go look at the SQL view for this statement, and let's make it a little more readable. And I don't think, is there a zoom on it? Let me just check now. Doesn't seem to be. Nope. Doesn't want me to change that. All right, let me read it to you. So if you can't read that. right, it says we're going to select student ID. Well, when you see student dot student ID, what does that mean?
Student, student table.
Student table.
Is the actual column.
Yeah, the column is student ID. So the dot is sort of, it's almost like, in object-oriented programming, we have object dot method. It's the same thing here, except it's table dot field, right? So student dot student ID, student dot last name, student dot first name, schedule dot course ID, courses dot title, courses dot credits, professor dot name, schedule dot grade. So those are all the fields I'm picking from. And then it says from student, inner join. So what's that going to do? What's an inner join do?
We're going to join the two tables together. We're going to join tables together, right?
Right. Inner join professor, inner join courses on professor ID, professor.professor ID equals courses.professor ID. What does that mean? Sure you do. If I'm gonna join, inner join, then this is, you have a join within a join within a join. There's 4 tables and there's 3 joins because they're all joined together. So one is professor is joined with courses. Professor, inner join, courses. All right. I'm going to join those 2 tables together. Those are both table names. Now we're going to decide what field I'm going to use to join them. In our professor ID field is the same name in both tables, so you have to specify professor.professor ID equals courses.professor ID. So where those 2 fields are equal, join those 2 tables. All right? So now that courses is joined to professor. Then also part of that coupling of those 2 tables is also joined with schedule and courses. So it's joined with schedule where course ID, course.course ID equals schedule.course ID. So I have these 2 tables, professor and courses, joined together. And then I have that joined together with, because I have a link between courses and schedule on course ID. And then I have 3 tables joined together. Then finally, the schedule table is joined to the student table on student ID equals schedule.student ID. So that joins the last part in. Does that make any sense? Should I do just 2 tables instead of all those tables?
So are you just
I can do
taking
that.
2 joins, and then once you take them 2 joins, then you're taking that information that you're getting from 2 joins, and you're going to take it to another table, that information that you got, and then match the information on that table with what you got the information from. So basically, if you have table A and table B, and they're joined by a C, are you taking all the information that you gathered from C? So basically, if they had 100 records and only 40 of them were joined at C, so you're taking the 40 records, and then you're taking them to table D and joining them at 2 other things as well out of the 40 records? Or is it still out the 100 records that you started with?
It's wherever there's a join between the 2 tables where these fields are equal, it will pull up a record.
But is that out the original amount, or is that the amount that you originally, is that the amount that you joined the first time?
When we switch views over to datasheet view, that's all the records that match. Now, if we didn't enforce referential integrity, we might have some missing records here. Or we might have some blanks. You might have a record like Joe Smith is in here, but he doesn't have any courses. Right? Or you might have Professor Jones who's not assigned to any courses. Actually, I take that back. That would be an outer join. An inner join, it takes it only, I think this answers your question, only where there's a match between student, courses, schedule, and professor. Where there's a match all the way across the board, that's the records that get pulled out. An outer join would be all the missing records too. But we don't really typically do outer joins. Just too much data. that make any sense? Kind of. All right, let's do a simpler one. All right. I'm going to save this as, let's save it. Yes. And let's call it, do I have a grade report already? I do have a grade report. Grades 1. All right, let's go right to SQL view. Instead, let's create a query design, and then I'm not going to do anything with these. I'm just going to write the code. Let's change to SQL view. Let's just see which courses are being taught by which professors. Just 2 tables. That'll be easier. And I'll show you 2 ways of doing it. Okay, so we want to select professor dot, I think it's professor ID. So one of the things when you're writing SQL code, you have to kind of know what all the field names are. Professor ID, comma, professor, you get to spell it right, dot name, courses dot course ID, and then let's do courses dot title. Right? We're going to select only those, and then the next line, from, and no, you don't have to capitalize this stuff. I do it to make it more readable. So I'm going to select it from which tables?
But didn't you tell it up there what table already when you said professor?
Yeah, so which table?
Professor?
Professor.
And courses?
Oops. Professor, comma, courses. I think it's courses. We'll find out in a minute. Now, I can do the inner join right there. Let's watch this. From professor, inner join courses on professor ID, professor ID dot, thank you. Courses dot professor ID.
Of course, it has the column name professor ID.
Yep.
Or I thought it was course ID.
It does have course ID, but to make that link, let me open up database tools, relationships. Here you go. Professor is, this will help me a lot. Actually, course is good. Professor ID here, and there's also professor ID here. There's a relationship there. Right? So I'm just doing these 2 tables, courses and professor. So I want a list of courses, and I want the professor name for each one of those. I should put the department in too. Professor name, professor dot department. So from professor, inner join courses on professor ID, professor dot professor ID equal courses dot professor ID. Want to see if that works? What's the worst that could happen? Doesn't work? Come back and fix it. Yay! I always hold my breath a little bit. I don't write SQL code every day. It's not like other languages. So I've done this. Okay, so I've got 1, 2, 3, 4, 5 professors. All right, so now, and I've done an inner join there. Now if I go back to my view, to SQL view, all right, so let's say I want to limit, or let's just say I want to sort it.
So if you don't put the inner join there, though, it still pulls that information, doesn't it? Still pulls all, you already told it what titles are full, what columns up there, and you're telling it which table.
You want to try it that way?
You don't,
Let me do this. I'm gonna copy this so I can put it back. You want to just say from professor, comma. Let's find out. So just select these fields from these tables without doing anything. What did that do?
you go to column, and then
It gave you every possible combination. You have 60 records there. It gave you every possible combination of records. This is basically an outer join, and you don't want to do an outer join. So.
it took the two tables that you gave it, which was the course table and the professor table.
Yep.
And any column that you linked up there, it printed out everything that was under.
Yep. Everything that was under professors, everything that was under courses,
Under the columns you named.
and then, yep, and every combination. So it's like every professor's teaching every course, which is not accurate, because I didn't do an inner join. I didn't do a join on these tables based on professor ID being equal in either one. I just said, give me all of everything. This is garbage. There's no use there. This is.
You guys would get a lot more money if you did that.
Yeah.
So basically,
If I was assigned to teach psychology, boy, wouldn't that be a blast.
basically all professor IDs are matching up to the titles that they're teaching, though, correct?
No.
The 976 professor ID, he doesn't teach English grammar.
No. You have Albright teaching computer science. You have Albright teaching. Oh, you have Albright teaching English grammar. That's pretty funny. If you knew Dick Albright, it would be pretty funny. Oh, and then Albright, who's teaching physics, and then you have Albright teaching accounting, even funnier. Then you have Albright teaching organic chemistry, Albright teaching intermediate sculpture, really funny. Albright teaching intro to biology. So you have all the combinations of all professors and all courses. There's not a relationship there, because Albright doesn't teach English grammar in this system. Because if I go and put my inner join back in, which I'm going to do.
I see what you're saying. So basically, it's just printing out everything that's inside that actual column.
It's giving me all possible combinations of professors and courses, whether they're teaching them or not.
Right. If it has the name under that course, it's going to be.
No, if it has a name, whether it's under that course or not, it's going to put it. So, what are you talking about? Change my view to datasheet view. What? How in the heck? Let's close the relationship, and let's try to run it now.
You got from professor. Is that right?
Oh, professor, oh, that was like I wanted to go from professor, sorry, inner join, there we go. So this shows you who's teaching what. Albright, it turns out, that's kind of funny, teaching biology. That's all he's teaching. But the way the other list was, since I didn't do it with a join, it had him teaching everything. He doesn't teach everything. So if you don't use the join, then you get an intersection, actually you get a union of both tables. Every professor and every combination of courses. So you can imagine if there was 1,000 courses, and well, there's 2,000 faculty members here on campus, right? Think of that, how many millions of records that would generate. So you don't want that. So I do it this way. There's another way to do this. Oops, we can go back to my SQL view. I can do this from professor, comma, courses, like that, without the join. But this is kind of an older way of doing it, but it still works. I'm going to say that, right? Where professor dot professor ID equals courses dot professor ID. This will do the same thing, but because the where clause limits what records will show. But it only where professor.professor ID equals courses.professor ID. So this is a more English-like way of doing a join, and it gives you the same answer. So if you're only joining two, well, I guess you could do it with others, where professor.professor ID equals, and you could do it and where student.student ID equals schedule.student. I guess you could do it for all those. And it effectively does a join using the where clause. But if I want to go back and do my professor using my join, oops. Let me go back and get that. All right, so I got that. Now I want to do let me do some selecting from this in a way. What do you want to do? You want to say where I don't know, let's say where let's go where professor name equals Carberry, right? So I'll print all of her courses. So I go in my SQL view, and I'm sure you guys did this using the where clause. Marcus, tell me you did that using the where clause.
On query.
One of the examples is where something equals, the ID equals.
Yeah, we did where.
Yeah, where.
Okay.
Like on the WMCRM database,
Yep.
we had to create a query that we named, if we just select customer ID, which has brackets. I don't know why we put brackets on it. Customer last name, comma, customer first name.
Oh.
From customer, and then where is from customer, not customer. ID where greater than 2. And then we did an order by.
You want to know where the brackets come from? When you have, remember, I think it was back in the beginning, I said when you define a field name, you can put spaces in the field name, but it does complicate things a little bit down the road. And then we said use the caption, that'll be the label. So if you have a field course and you want a space ID, create a caption that says course space ID. Name the field course no space ID. Because if you make it course ID with the space and you put that in an SQL statement, it sees that space and it thinks course and ID are two different fields. So you end up having to put these brackets around it in order for it to interpret that as one field name. So it complicates it a little. And for me, God, if you think about a system that you're working on could get large. And you're going to have to remember that, there's this one table way over there that has this one field that somebody put a space in the field name, and I have to remember to put brackets around it every time I include it in an SQL statement. No thanks. Do it this way. Then I don't have to do that because, and by the way, if you were working in a grand professional setting, there would be conventions about how you would name fields and tables and all that stuff. They would tell you how to do it. And they wouldn't say just sort of do it any way you feel like. It's not job security, folks. It's not. You won't make it to lunchtime if you don't do it the way they tell you to do it. So this just, I don't like this. Just do that, and then I make a caption that says course space ID, and then I don't have to worry about it. I just call out the fields, and I know that Access has the data dictionary already established for the definitions for all those fields, and it'll handle them appropriately. So, and I think in this one, schedule has a course ID with a space in it. I have to fix that. All right, so I wanted where professor dot name equals Carberry in quotes. I put it in double quotes. So this kind of gets really English-like if you think about it. Select professor dot well, I'm going to just not say the table names. Select professor ID, name, department, course ID, and title from professor interjoin courses on professor ID equal professor ID. So that's a little cryptic. Where professor.name equals Carberry. Now let's see if that works. Drum roll, please. That. So under the name field, this doesn't delete those other records, but it just says that we're only going to show the records with we join two tables together, professor and courses, and we've shown the relationship between them by Carberry teaches 3 courses, and we're only going to show those records where name equals Carberry. So when you join the 2 tables together, it's like it's one big table. It behaves that way. Does that help? Yeah? Am I putting you to sleep? Be honest, I don't care. I can put anybody to sleep. If this was, I used to teach an intermediate database class, it gets kind of theoretical, and you're talking about hash tables and hashing algorithms and stuff like that. Put you right to sleep. It's like a big chloroform bomb goes off in the room when I start talking about that stuff. Any questions on this? Got it? Marcus? You look bored, man. Is this not challenging enough for you? Yes.
Do you have any like external books or any reference you can reference us to like study SQL command in lang, like practices examples?
I think in the syllabus there was some stuff, but those links are a little old. If you have the syllabus, let me go back. Those links are a little old. If they don't work and you try them, please let me know.
From the sample tutorials.
Yeah, there's sample tutorials. If you know what, the other thing too is, I mean, my son, whenever he wants to learn something, he's 13, whenever he wants to learn something, he gets on YouTube, and there's always a YouTube guru out there that'll teach you something. Yeah. Code Academy?
Where's that at on the sample tutorial? Where is that?
I'm going to bring up the document. No, ask me later. Yeah, I have a friend who he bought, bless you, he went to a yard sale. His wife is a big yard sale person, and she found this old safe. There was an old antique safe, and the guy who owned the safe says, I got it from my grandfather, I don't know what's in it, and I don't know what the combination is. So my friend Bill buys it for his wife, and she's like, I like this thing. All right, so he lugs this 100-and-something pound safe back to his house. He says, now what are we going to do with it? And she says, it'd be nice if we can get it open. And so he's thinking about blasting it open or something. Then he says, let me get on YouTube. And he types in how to pick a safe. And somebody had a video out there, how to pick a safe. And he got it open. And I was like,
Yeah, what's in there? I feel like there's a story.
Tell me there's gold inside.
there was nothing in it. Unfortunately, there's someone that's like, who was it? Geraldo Rivera did Al Capone's Vault. You know that? Did you ever see that? I saw that live. That was pretty funny. Nothing in Al Capone's vault except the underside of a staircase. All right, here's one here. Control and click. Let me hit this and see if it. See, these are a little older. I should update these, but these are able to open. The internet site reports that the item you requested could not be found. So some of these links are not actually links anymore. So I will have to update these. Here's a tutorial for SQLzoo.net. Select basic, select within select. There you go. Join. Here you go. Even with some diagrams on how to do it. Games, goals, teams. That's pretty cool. But oh, I guess, yeah, you can put in your own code. Ah, so it gives you the answer here, I guess.
But it gives the answer, and this is wrong answer.
Too many. Oh, that's the wrong answer. Too many columns. Anyway, the SQLzoo.net is one that can give you some exercises to try. In this course, I'm not going to have you guys. When I was in graduate school, I took an intermediate kind of database class where all we did was SQL for a whole semester. After a while, you start dreaming in SQL and start talking to people in SQL. We're not there. We're just going. This is just to give you an overview of SQL. If you can do some selects, inserting, updating tables, this simple stuff. The thing about, Marcus, you mentioned about cascading and that stuff.
Yeah, there's a bunch of different functions in here that.
If you have to do cascading in the homework, go look it up. It's in the book. I don't know it off the top of my head.
We don't.
I don't.
Referential integrity that we have to set up, so I'm assuming we got to create the database, put the data in there, and then I guess we got to go back and do SQL language of how to enforce the referential integrity on the database, and then you want us to show the database, because I don't know how we're going to do it in Word, but you want us to show the database and show the code as well.
You can just submit the database. If you wrote the SQL code and it's in a database, submit the database, because I can click on it and see if it runs. Because if you submit it in a Word document, then what do I got to do? I got to copy and paste it into a database, and I got to go populate the database. I got to go build a database. If you've got a database with code with it in there, just send it. Yeah, that's what you do. Yeah, I'm sorry that this wasn't as clear as I thought it was, but yeah, it doesn't have to be. We're not. The idea of this course, this is a 2,000 level course. If this was a 5,000 level course, it'd be a different story. We'd be trying to make you SQL programmers from the get-go, but it's not. It's to give you a basic understanding of how a relational database works. If you're an IFS major, information studies major, that's going to help you when you go on to other topics, such as when you take the advanced web programming course. I keep forgetting what the title of that course is, but there's the beginning one, 3361, and there's the 4,000 level one. They're going to teach you how to implement a back-end database, so a server-side database. And if you don't understand how a database works, you're going to be lost. That's why you're in this class learning how this works, so that you will understand how databases store and retrieve information. Just as one application, that course teaches you, using MySQL and PHP, how to set up a back-end database and how to access it and how to send commands to it. And it teaches you the theory behind it. So if you don't understand what a relational database is, you're not going to have much success in that course because you're going to be lost. So you need that. And relational databases are extremely common. So, from anything from keeping your son's baseball schedule to, running a Fortune 500 company. They're all over the place. And, I haven't had the need to develop my own database in a long time, but there were occasions back in the day where I did. I wrote my own code, I wrote my own programs, and I made it do what I wanted it to do. So understanding this will help you. If you're becoming an information professional, that's the purpose of this course. It's 2,000 level. You notice that every chapter, we take 2 weeks to do one chapter, and the chapter is more pictures than words. That's the idea. I don't want to make this any more intimidating than it has to be. This stuff is just fun. Mess around with it. What I would say is build a query using the GUI front end, and then go see what the code looks like. Then try manipulating the code and see what happens. That's how you learn stuff. It's easy. I got this one. I only did the select, and I did the join, and I did the where. I only got a few minutes left because I got to go to a meeting, but let's do this. How about this? What is this going to do? Can you read that? Title. So what's going to happen? How many records am I going to have? I had 3 before, all for Carberry. Am I still going to have all for Carberry? My where clause, where professor.name equals Carberry. So that's still in play. So I'm only getting her 3 courses. Right, so I'm only going to get those 3 where her name is on there, and then within that grouping, I'm going to order them by course title. Let's see if it did it. All right, accounting comes before general engineering, comes before organic chemistry.
So you didn't have to use one of the titles that you actually specified earlier. You didn't specify title in there earlier. You specified course ID and
yeah, I did.
Stuff in your SQL code.
Yeah, I did. It's up here.
Oh, I see. Okay. Cool.
Now, what if I do this? What will this do? I took that out. So it says select professor ID, professor name, professor department, course ID, course title from professor join courses by blah, blah, blah. Order by professor.name, comma, courses.title DESC. So is the professor name going to be ordered ascending or descending? Ascending. And then within that group, so I'm going to order all my professors in ascending order, and then those professors that teach more than one course, their course titles will be in descending order in those groupings. It's not that hard. What do you see? It's easy. By the way, if you have a field in a table called description, you have them for all kinds of things. Inventory, you might have a description of an item. Don't name the field DESC. It'll give you some bizarro error message, and it won't happen until you start running queries, because it'll think you're trying to order something in descending order. DESC is a reserved word in SQL. It means for ordering something in descending order. All right, let's see what it got. Yeah, same thing with dates. All right, so I've got Albright is my first professor, Carberry, and I have all the Carberries. then Child, then Flanagan, then Saunders. Right? So those are all, the professors are all in order. Some professors teach more than one course. So within that, they're like Carberry is right here, and she teaches 3 courses, and they're in that grouping is in order in descending order by course title. Isn't this cool? You guys are lying. It's not that cool. Yeah, it is cool. Yeah. This is a survival skill. When you get out there in the information professional world, this is going to be a survival skill. It can be a really powerful tool. I worked with a guy when we were in the defense business. I worked with a guy who he came to me and he says, "I heard you understand SQL." And we all worked for the same company. I said, "Yeah." And I was in graduate school taking that course where I was thinking in SQL. All right. I said, "Yeah, I'm working on it in school right now." He says, "Can you help me?" I said, "What do you got?" He says, "I have a 25,000 record database that I got from my client over at the base, and he wants reports based on certain things." And he says, "And I have no idea where to start." And fortunately, actually, he had it on a spreadsheet. 25,000 records on a spreadsheet. So first thing we're going to do is we're going to import that into a database. And he goes, "Okay." So we get it into a database. And I said, "Okay, Scott, what do you want?" He says, "I need it by it was a failure modes and analysis report of a computer system, and it connected to some device. I forget what it was. But every part that was in that system had what I call a mean time between failure and a mean time to repair value. And they were trying to figure out the reliability of the system. When was this thing going to break? You know, so if they run it normally, is it going to go 10,000 hours? How many thousand hours? Because it was going to go in a submarine. So they want to know that stuff. If it breaks, can we fix it? Every stinking part, every switch, every circuit, every 25,000 parts in this thing, and they had all these specs on how long it would last before it broke. He says he wanted to find out which were the most critical things, and I just sort them in descending order by in ascending order by mean time between failure. So the shortest time for failure will be at the top, the longest will be at the bottom. And he says, "You can do that?" I said, "Of course I can do it. Watch." Select all from this table. I was like turn on my SQL engine in my head, and I started doing this. There you go. And he goes, "Oh my God!" You know, it was like, "This is brilliant." So I said, "What else do you want?" He said, "You want to print this out?" "Yeah, print it out. And so, you know, one of them we printed out, ran overnight, but it was just by doing some simple SQL commands gave, you know, this was way before big data, right? And this gave the customer, like the client, a real picture of what the system they should expect, because it was a brand new system going in a submarine. They needed to know the maintenance requirements for this thing, and they had to do this kind of predictive analysis to figure out when is it going to fail, what's going to fail, and how long does it take to repair it. As it turned out, one of the things that was going to fail the quickest took the longest to repair. That made everybody stop breathing, because they're like, "Oh my God, we got to rethink how we're going to do this, because we're going to either get faster at repairing it or make it redundant." So you can get a lot of cool information just by doing these simple little commands.
How complicated does SQL get?
It can get, I mean, just like anything, you can make it as complicated as you want. If you go and look up, you know, if you buy an SQL manual, like a coding manual, and you get every last command that you can use in SQL, it'd be pretty extensive.
For the most part, the things used the most are the more simple things that we're learning today.
Yeah. If you can do this stuff, you can join 2 tables. If you can join 2 tables, you can join 10 tables. Selecting fields, putting a filter on there, basically a where clause, where student.GPA greater than 2.0 and student.GPA less than 4.0, where major equals business and athlete equals false. That'll give you, I mean, the language gets very English-like. You can figure out what that is. I want people with GPA between 2 and 4 who aren't athletes who are business majors. That, as you get a little more, the details about, where do I put the dots and the commas and all that stuff, you'll figure that out really quick. You'll figure that out really quick. And if you have a query that does something and you want it to do something really similar, you're going to copy that code and be a lazy programmer in a good way, right? Copy that code and paste it over here so you don't have to write it all over again. And then modify it to what you want to do. Get the point? The whole thing about cascading, Marcus, you brought that up, and that's in the book. And if it's in the homework, I would say just go look up how to do the cascading command. I don't know it off the top of my head because I don't use it. And I don't expect you to use it a lot either. If it's in the homework, figure it out. Wow, that's cool. Next. Okay. Any questions? If you want, are we still on SQL next week?
Right now,
I don't have.
next week we have,
Next week will be database project.
October 2nd. No, we're still doing SQL.
we're on week 6 right now.
Yeah.
Yeah.
We're,
That's this week.
oh, yeah, sorry. Data modeling, ERDs. Oh, yeah, you're going to love that stuff. That's cool. Entity relationship diagrams. All right. Yeah. So we're going to depart from SQL. So we only spent, 2 weeks on that? So, but really, seriously, don't lose sleep over, if you don't know how to use every last command that's in that chapter. I'm surprised they gave you cascading. I haven't looked at that in a while.
Yeah, they gave us a lot of them that we, I didn't see you using, just a lot of commands that we,
If somebody said to me, I want you to go and build an entire database using SQL from the create schema command, which is creates the database file, all the way to the queries and reports, I could do it, but you know what I would do? I'd get a book like that, and I'd say, all right, how do I do a create schema? How do I insert a table? How do I create a table? How do I modify a table? How do I do? Then go do it. Nobody, if you're being introduced to something new like that, nobody expects you to, let's say 5 years from now, nobody expects you to remember off the top of your head the SQL code you wrote in this class today. Not going to happen. If you do know it, they're going to go, I don't know, that guy really doesn't have much of a life or whatever. This person's kind of weird. Remembers SQL code from 5 years ago. Sit them down, make them write code, but don't go out bowling with them afterwards or whatever.
So when we're joining multiple tables,
Yes.
2 quick questions. The first question is, so when we join the third table, we join the first 2 like we just did there.
Yeah.
Very simple. When we join the third table, it's taking that information because it's ciphering the information out, right? When we're doing a join, we're taking the 2 tables and we're going to tell it where to join at. So like we said, we did Professor ID. So it's going to take the 2 tables, take Professor ID, whenever they match, it's going to print all the titles that we told it from the top, right? For that row, right?
Yep.
So when we do the third table, is it going to take just only the ones that ciphered out from the first 2 tables, and then it's going to link the third table with only the ones that ciphered out from the first 2 tables, right?
The one where there's a match, right?
And there's going to match out of that. So the next third table is going to have a column from the third table matching up with the column from which either the first or second table?
Yep. Yeah, it could be one or the other. Yeah. So, see, it shouldn't, it usually is not in a circle. If you look at the diagram here for the relationships, as long as it's like the International Space Station, as long as something's tethered to something else, you're good. That we can get to it. Yeah, no. And, don't let it be like Space Station Mir. No, it just doesn't, no, don't worry about it.
And the second question was, when we're doing these multiple joins, the first one we did, we said join, we said join on, and we said something in join.
Inner join.
Inner join, and then we did basically the table first, inner join, second table, and then we use the word on for basically what we want to join it together with. Once we're done with them two, we want to do another table. Do we use the word on again right after that, or?
Yeah, you know what I would do? You want to know exactly where the parentheses and all that go? Go into here. Let me get a student grade report, right? This is if I go into my design review. Let's see, I've got for one specific person, I have it sorted, and I have 4 tables, right? Go in and create one this way. You use all 4 tables, or however many tables you got, and then go look at the SQL view, and then I'll show you exactly how the inner join works.
So is that, them 4 tables are interjoining each other?
Yep.
And how did you specify that on the 4 tables? Not
This one, I built it this way.
So on that data view, what part of that is telling us where to join it? Are we interjoining the student IDs? Are we interjoining?
Student is going to do an inner join with schedule. Schedule is going to interjoin with courses, and courses is going to interjoin with professor. And if you pick apart the SQL in this, you'll find all of it. It's all there. This is just, I mean, I know we've said this before. This is just a graphical representation, a graphical interface for this. It's just an SQL code generator. That's all it is. It created that code. So that code does what that picture does. The picture is just easier for us to manipulate. You know, when you hit check boxes and you pull down menus and all that stuff and you select all these things, it's easier than writing this code. Especially if you're not really planning on being an SQL expert. That's all. That's all. Don't let it intimidate you. It's not that hard.